Woohoo, we are live. This is Math 40, Elementary Algebra. This is section 2.5, and I've gone ahead and collected up a couple, well, actually three of representative word problems in this section. So in this section 2.5 and 2.6, we're going to be working on more word problems. 2.5 is a little bit of a mixed bag, so I've tried to pick three that will help you with as many of the homeworks as possible. Some of the homeworks you're just going to have to approach on a one at a time. And again, I'm going to tell you, never spend more than half an hour on any of these problems. Please ask for help. Come talk to me. Talk to a tutor. Talk to the other students in the class. Say, give me a hint. Help me out. And we can totally send you in the right direction. Do not spend 3 hours trying to get through a single word problem. It's not going to help you at all. It's just going to take up your time. And that's not really a good way to study math. It's just going to make you cranky. And no one needs to be cranky, especially with word problems. So I have selected a couple of my favorite puppets. This one's Sparkly Vampire. This one's my shark. And they are going to be here as my support puppets while I get through the word problems. Because again, word problems, not simple at all. So let's go ahead into the brave new world. The first one says it's about first aid. A sling is in the shape of an isosceles triangle with a perimeter of 144 inches. So already we know we're dealing with triangles. And I realize I'm going to have to look up isosceles unless I already know what it means. Isosceles is a really interesting word. And the nice thing is you see the word iso, which means same or self. And what usually people do to draw them is they'll do something like this, which first off looks really cool, right? So basically, even though my drawing is rubbish, you can see if I put a single line through here and here, that means these two sides have the same length. Isosceles means at least two sides have the same length. It's possible that all three do. We don't know that. So I mark this one as different just because I don't know, but it's possible they could all three have the same length. Okay, so I've got my triangle, and it has a perimeter of 144 inches. Now it says something else interesting. The longest side of the sling is 18 inches longer than either of the other two sides. I'm going to write that out. The longest side is 18 inches longer than the other two. So that tells us that one side really is longer than the other two. So they're not all three the same side. So this is the longest side, I think, because it's the one that's by itself. It's the one that's different. Find the lengths of each side. Okay, so I've got a sling in the shape of isosceles triangle. Yes, with a perimeter of 144 inches, got that. The longest side of the sling is 18 inches longer than either of the other two sides. Find the lengths of each side. Okay, so I am going to label these. I'm going to label this as A. And I'm going to label that as a length. So I'm also going to label this side as A because they have matching lengths. And then I'm going to call this one B. So the length of the longer one is B. So first I'm going to look and see that I have the perimeter is 144. Perimeter means I start at one point and I go walking all the way around. So basically I add all the sides together. Side 1 plus side 2 plus side 3 equals the perimeter. So I think I've got A plus B plus A, or 2A plus B, right? Because 2A's plus B, and that's going to be 144 inches. So I've got an equation. Nice. Okay. Now I have an equation here, but I can't solve it because there are two variables. And we in this class don't know how to do that yet. Will you eventually be able to solve equations in two variables? Yeah, sometimes, but not right now. So if it's got two variables in it, we don't have enough. Okay, so I'm going to leave that there. I know that's true. Nice. Now I also have this line, which I pulled all the way out because it was interesting and difficult enough to do that. So I'm seeing the longest side is 18 inches longer than either of the other two. I'm going to do a direct translation. The longest side, ooh, there's something under my paper, sorry. The longest side, which is B, okay, is, remember we've got is an equals 18 inches longer. So I've got two things to look at. One, I know 18 inches longer is going to be something, but also I double check that my units are matching. I've got inches, I've got inches. If the perimeter were in feet and this is in inches, then I'd have to do something about that. But they're both in inches, so we're good. Okay, 18 inches longer means plus 18. And then what is it longer than? Then either of the other two, what was the length of the other two? Those are length A. So in other words, I've got B is just A plus 18. Okay, interesting. This is true, but it also has two variables in it. So I'm going to take my other one, 2A plus B equals 144. So I've got two equations and I've got two variables, which I can totally solve. And let me show you how to approach that. Here's the thing. There's this thing called substitution. If two things are equal, you can replace one with the other. It's kind of like if you've ever seen like a sitcom or a movie where there are twins and they play a joke on their teachers because they're like the one twin will go into class in place of the other twin. It's just like that. B and A plus 18 can take each other's places, have wacky adventures, go on dates with the other one's girlfriend or boyfriend. So the wacky adventure we're going to have right now is if B equals A plus 18, I'm going to look right here and I'm going to see, wait a minute, I've got 2A plus B. So that could be 2A plus, and where the B was, I could put the wacky twin, A plus 18, because B and A plus 18 are equal. So I can replace that. Now, what is the benefit of doing that? Well, the benefit of doing that is then I've got 2A plus 18 equals 144, or 3A plus 18 equals 144. And then I'm going to need some more paper. So let me grab another piece of paper. And I will copy it down because, again, you never do any work in between. I mean, you could, but I can't. You guys might be able to. I can't do that. Okay, so now I've got an equation to solve. I'm going to subtract 18 from both sides. What do you guys think? So I get 3A equals 1, and then A. No. That was, look at my brain doing a funny thing. My brain, oh, my poor brain. It tries so hard to do a good job, and sometimes it just gets everything backwards. Let's try that again. It's going to be 126. There we go. And then I'm going to divide both sides by 3. Now, I'm hoping as we're doing this, the word problems, the hard part is getting to the equation. I'm hoping that by now solving the equation is becoming easier and easier to do. I get A equals, and then if I do this in my head, which I wouldn't trust my head, I got 42. Woohoo, am I done? So let's look at the problem. It says, and usually you go to the last sentence, it'll tell you what you're supposed to tell, what you're supposed to answer. Find the lengths, yeah, I got a length of each side. Oh, so the length of this side is 42 inches. And in fact, that's the length of both of these sides, but it isn't the length of the longest side. Now, what can I do to get to that? Well, we do have this equation right here where b is just whatever a is plus 18, which would be 42 plus 18, which would be 60. Now, does this make sense? So let's take a look at this triangle. And again, I'm going to use the magic words not to scale because this is supposed to be much larger. This is 42. This is 42. This is 60. Does that make sense? If that's my triangle, if I have my perimeter, it's 42 plus 60 plus 42, which is equal to 144. Is that what I was supposed to get? Yes, it is. Nicely done. We did it. Okay, now, a couple things to answer. As far as I'm concerned, if you gave me the picture, I would accept it. Now, some teachers are going to be more picky, so they're going to want 42 inches, 42 inches, 60 inches. And you might ask me, wait, which way do you list a triangle? And the answer is you can start with any side. Does not matter. So I'm starting 42, 42, 60. You could do 42, 60, 42, however you like. Woohoo! Okay. So this is the new world of word problems. It won't be unusual to use more than one page. Please don't try to write so small that this is not where you save your paper. If you want to save paper, write on both sides. I don't, because then when I go to scan it, it's just muddy and you can't read it. So I have to write on just one side, but you guys can write on both sides. Or, use scratch paper, use recycled paper. I'm just going to get myself another piece because I know this is going to take a little bit. Okay, a rock group plans to travel for a total of 38 weeks. Total of 38 weeks. I'm doing like what I did before. As I read through, I'm making a note of any numbers I come across, making 3 concert stops. 3 concert stops. Okay, then it gets to be blah, 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 blah. They will be in Japan for 4 more weeks than they will be in Australia. Their stay in Sweden will be 2 weeks shorter than Australia. Oh my goodness. So I've got Sweden. And I believe Japan is a little lower down. Japan. And then I want to say Australia is kind of almost just below Japan. I may be a little fuzzy. And already you probably know the magic words that I'm going to use. Not to scale. I'd have to pull out a map to get the distances right. But I got a basic description of what's happening. We've got Sweden, Japan, and Australia. Okay. How many weeks will they be in each country? It's a total of 38 weeks, 3 concert stops. So let's see. I'm going to say Sweden plus Japan plus Australia equals 38 weeks. Those are the 3 concert stops. And I'm realizing, when I write this down, I really should have some variables. I shouldn't be using whole words. So I'm going to say, let S be the number of weeks they spend in Sweden. Okay, and then I'm going to say J. These are ditto marks. If you've never seen them before, they're the most brilliant thing. They mean whatever was right up above, say the same thing. So here I am being very, very, very lazy. Ditto, 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 Australia. Okay, so I've got some variables. So now I can write S plus J plus A equals 38. Now let me stop for a minute even though I was lazy, I was not lazy with the first one. And let's take a close look at that. I didn't just say let S equal Sweden. I said let S equal the number of weeks they spend in Sweden. So when you declare your variables, try to be very descriptive. Okay, I still just have this. So this is an equation with 3 variables, and I've got nothing else to go on. So I need to look again at the problem. A rock group plans to travel for a total of 38 weeks. Yep. Making 3 concert stops. Yep. And then I get to the thing that kind of boggled my brain the first time. They will be in Japan for 4 more weeks than they will be in Australia. They will be in Japan for 4 more weeks than Australia. I ran out of room, so I'm going to say that. And I look at that and I go, wait a minute. Japan equals Australia plus 4. What do you think? They will be in Japan for 4 more weeks than Australia. Now, here's the thing. Writing this down, I don't think was obvious. I think the fact that there's a 4, that's obvious. The fact that it's Japan and Australia, okay. But I think a lot of people would be like, yeah, why didn't you put the 4 on the other side? Let's talk about how to set up an equation. So we're going to take a brief break, and I'm going to talk about teeter-totters. Teeter-totters, I don't even know if they exist anywhere anymore. Basically, they're little things that they're balances. And you generally, a lot of times when I've gone to teeter-totters, it was me on one end being an adult and a child, and you don't actually stand on it, but I can't draw us sitting on it. So there would be an adult over here and a kid over here. And if you really just had it like this, if there was an adult on one side and a kid on the other, what would happen to the teeter-totter? Teeter-totter would go bonk. And the person on this end would hurt themselves a lot because the whole thing goes bonk really fast. So if I have a much heavier adult who wants to be having a great time and a much lighter kid, and I had a big weight, where do I need to put the weight to keep them balanced? You have to put the weight on the side with the kid to balance it. Does that make sense? So you put the extra weight on the small side, not the large side. You put it on the small side. So the adult is equal to a kid plus some amount, depending on how big the kid is. Does that make sense? Okay. So having said that, oh, my papers are stuck together. That's exciting. Let's look back here. They will be in Japan for 4 more weeks than Australia. This is strange English. This is the way English is set up. So Japan is longer. Australia is not as long. So Australia is little and Japan is big. And so how do I balance the equation? I put the +4 over here. Okay, let's look at the next sentence. Their stay in Sweden will be 2 weeks shorter than that in Australia. Sweden will be 2 weeks shorter than Australia. Okay, so I got Sweden on one side, I got Australia on the other, and then it's 2 weeks shorter than Australia. So Australia is bigger. So either I could put an extra 2 weeks over here, or I could say it's Australia -2 because it's 2 weeks shorter than Australia. Does that make sense? So on the teeter-totter, So on the teeter-totter here, instead of adding a weight, if I had balloons with helium that they could kind of lift up the teeter-totter, where should I put the helium? To balance the two, so this weight was pushing down, this helium balloon pulls up. So if I want to use a helium balloon to balance this, what would I do? I would take the bigger one and I would add a helium balloon, which would subtract some of the weight. So I subtract 2 from the larger one. Australia is, so Sweden is shorter than Australia. So you start with Australia, you take away 2, and that equals Sweden. So far, so good? Kind of, sort of. This is a hard one. This is a particular category called a safari problem. They show up all the time. I'm not sure why. People love these. Okay, let's take this nice clean piece of paper and let's write down all the things that we have that are equations. So I've got an equation right here that says Sweden plus Japan plus Australia will be 38. I've got another one right here, number 2, that says Japan will be 4 weeks longer than Australia. And then here 3, I've got Sweden is 2 fewer weeks than Australia. Okay. So then what can we do with these? Well, let me suggest now we have 3 variables. Now we are going to study this formally later, but I'm just going to show you how to do this now because I think you guys can handle it. Start out with the big equation, the equation that has all of the variables in it. S plus J plus A equals 38. And in place of S, so in place of S, I'm going to put A minus 2. And in place of J, I'm going to put A plus 4. Now, where did this plus come from? It's this plus right here. So this plus comes right down to there. This comes here. And then this comes plus. And then A comes down. And 38 just hangs out. And then wait, look what I did. I substituted. This is called substitution. Oh my goodness. I have been talking so long, I just ran out of ink. Okay. Oh, I've got backups. Don't worry. I know you were all like, yay, math is done. No, math is not done. I have boxes of ink cartridges for this thing because I run out of ink all the time. Okay, so substitution allowed me to take this mess of things. And basically, I took all these equations and I smashed them together. And I've got A minus 2 plus A plus 4 plus A equals 38. I could use the commutative property. There are 3 A's. Minus 2 plus 4 equals 38. Minus 2 plus 4 is basically the same thing as plus 2. And then I subtract 2 from both sides. 3A equals 36. And then what? You guys know this. You can do it. 3A divided by 3, 36 divided by 3, A equals 12. Now, if I know Australia was 12 weeks, how do I find the other countries? Japan was A plus 4, which is 12 plus 4. And then Sweden was A minus 2, so that's 12 minus 2, which is 10. So Japan I use capital J, sorry. Japan was 16 weeks. Sweden was 10 weeks. And Australia was 12 weeks. Woohoo! Now we can do a quick check. 16 plus 10 is 26, plus 12 is 38. Woohoo! So now we're getting into more excitement. This word problem took 3 pages. Okay, so these are not going to be short. Can we do one more? Why, yes, we can. We can totally do one more. The 3 numbers of the combination for a lock are consecutive integers and their sum is 81. Find the combination. Now, this is kind of the opposite of the previous problem in that the previous problem gave you lots of details and lots of things, you know, plus 12 and minus 2, and this tells you almost nothing. So we've got 3 numbers. We know it's a combination lock, so it's one of these guys or something similar when you've got the dial and you turn the dial around and it's got the numbers on it. So either the numbers are actually on the front like that, or else sometimes it's down at the bottom. Sometimes they do those combination locks like this. Something like that, where you have to spin the different numbers to get the correct combination. And what we're told is of these 3 numbers, they are consecutive integers. So I want to stop right there and say, what does consecutive mean? Consecutive means one right after another. So what would be examples? 3, 4, 5, 6, 7, 8, 13, 14, 15. Something like that. Now, what I could do is I could just keep trying different ones till I get to their sum is 81. But remember that we're not actually solving this problem. This problem does not need to be solved. This is an example of a problem that you can practice your solving skills. So I'm going to need a variable. I'm going to say the first number is n. And then I'm going to ask you what the second number is. No, a lot of people would be like, oh, I'll pick another letter. And I'm like, no, use n. What does it mean to be consecutive integers? How are they related? From 3 to 4, from 6 to 7, from 13 to 14. What am I doing? I'm adding 1. You got it. And so for the third number, I'm going to add another 1 to get to the third one. So it's n plus 2. Okay. So now can I take the sum? Sure. I can do the first number plus the second number plus the third number equals 81. So that's n plus 1 plus n plus 2. Well, that's just n plus 1 plus n plus 2 equals 81, which means what can we do? We can combine like terms. N, 3 n's plus 1 plus 2 equals 81. Or 3n plus 3 equals 81. Let me grab some more paper. Three n plus 3 equals 81. Okay, we're almost there. This is very exciting. Are you guys excited? I am so excited. 3n plus 3, subtract 3 from both sides. 3n equals, what's that, 78? 3n over 3 equals 78 over 3. N equals 3 goes into 7 2 times 26. Is it 26? Woohoo! Am I done? Let's look at the problem. Says find the combination. Okay, wait, I gotta go back to where I said what the combination was. The first number is n, so it's 26. The second number is n plus 1. What's n plus 1? 27. And the third number is n plus 2. 26 plus 2 is 28. You guys got it. Woohoo! You're awesome. Okay, I know this became a very long video, but let me show you one more thing. So this is a brain teaser. Consecutive even numbers. If I start with n, what's the next one? The next one is n plus 2. Well, let's look. Consecutive even numbers. 2, 4, 6. How do you get from 2 to 4? You add 2. How do you get from 2 to 6? You add 4. So instead of being n plus 1, n plus 2, it's n plus 2, n plus 4. Okay. What about consecutive odd numbers? If I start with n, let's take a look. 3, 5, 7, or maybe 11, 13, 15. How far is it from 3 to 5? It's 2. How far is it from 5 to 7? Interesting, it's 2, just like with even numbers. Why is it 2? Well, it's not 2 because it's even, it's 2 because you skip over. Plus 2 means don't go to the next one, skip over one. Oops. So the really cool brain teaser here, and for some people it's not brain teaser at all. It's just like, oh yeah, that's fairly simple. But the really cool thing is if you want to model consecutive even numbers or consecutive odd numbers, you use this same pattern. You guys did it. Woohoo. We're at 33 minutes, just under. You guys are awesome. Okay. Next up, we'll do some work with more word problems. Woohoo, in 2.6. Math on, guys. Yes.